already relevant information since we're just starting up, but this week is sort of going to be, well, to start, this morning I looked through a lot of the projects that are uploaded. Almost all of them I got through, and I'm really impressed with the work that you guys are doing and have done. And I also read in the Padlet how much work it really is, and how much you guys poured into this. I know it's a really hard project to do for some of us communication wise because we're not face to face, but I do feel it's good to sort of go through the process and, you know, making projects and talk in front of people and even learning how to make videos at this point is just sort of like basic college stuff that goes on. And so I figure if I can give you some helpful feedback in this sort of a low stake environment, then hopefully I can help you along the way a little bit, and we learn from each other. And really, the stuff that I've watched, the videos that I've watched so far, probably about half of the class, have been really, really nice and really well done, and I've learned a lot from them, and I'm still working on some. If you have a problem, done this week yet? Now this week I opened the discussion for the video. So now that we have done, you know, we've learned a lot about anatomy, physiology, how the body works when it really works well, and now we've also have worked on one pathology, which is when the body doesn't quite work as well, when something goes a little bit wrong. And we've also then now made a video presentation. So now we're going to upload those into a discussion forum. And I want you sort of have a little description of what you're talking about in yours, what the pathology is, and, you know, sell your video a little bit and say why the other person should be interested in it. And then upload the video link with it. And then as then the second step, that's the initial post. And then as the reply, I want everybody over the next 2 weeks, we keep this discussion open for 2 weeks until the end of the semester, pretty much actually. Yeah, we can probably even keep it up till the end of the semester. And then everybody, I want to watch two videos at least of other people. That is stuff that's interesting to them. And then give your classmates feedback in terms of, you know, the main points you learned and what they did well, how they worked well, and then also give them one constructive point that they can improve upon, because it's very different from doing something like that to being the viewer of that. And so I want you to sort of also learn how to be good in writing, you know, a little, or audio. You don't have to do written or video. Give a little positive critique. So you do that sort of sandwiching in a way that you first, you know, tell the person something that they really did well, what you really liked, and then you can point out a part, not what a part of the product that could be improved upon. Like, you know, sometimes we speak too fast, for example. That's a big one in these presentations, or sometimes the slides are too small written and we can't really see it. So those are, you know, things like that. And we can point one of those things out, because then that person can learn from that. And then at the end, you know, you can, at the third part of that sort of approach is then give them a step to how to do it. Well, if the text is too small, you can make the font bigger and make 2 slides out of it, for example, which a lot of the times is what my initial feedback is about. And yeah, don't take my way of feedbacking you as the best way of doing it, because I sometimes just go possibly a little too abrupt, because I just have to kind of go through it. This is one of those projects that I try to put a lot of time into grading. So that's good for that. Any questions to this thing, the presentation? Now that we're just saying hello sort of to everybody.
Yeah.
I had a question. Could you, after class, show me who I'm in a group with? Because I tried to communicate with them, I want to say like yesterday, but I didn't get an answer from anybody.
All right. Well, yeah, if you have issues with doing that's the other thing I wanted to say. So this discussion stays open for now till the 26th. So don't just go and finish it up too fast, because most of the class has not finished making the video yet. About a third has done it so far and uploaded, and so this is sort of the week to double up on that, because sometimes technical difficulties. One of them I couldn't hear, so we have to go back and forth a little bit. So it's in a usable format, so the work doesn't just go to waste because we can't see it. And then, yeah, like communication things. So now is the time to reach out to me, and I also try to reach out to you. Some of you guys we talked already about that it is not going to be up on time, so to speak. But again, my timelines are somewhat fluid, but we're trying to get it done this week if we can. And then we have the discussion open for 2 weeks for people to sort of finish up with going through each other's videos and writing a little commentary or making a little video about it and learning from each other to sort of finish up the semester. Is that sensible?
Yes.
All right. And then Jeff, Jeff, I know I interrupted you. You were starting to talk.
Oh, yeah, no, I was just saying we need to connect to and figure out the timeline for my group.
Yeah, and you just connect with your group and then get back.
Yeah.
To me when it's really not fully a rush. Again, we keep the hard deadline, and this is maybe the next point I need to bring up in today's discussion is the 26th is a Friday, and that's when Canvas closes. So be really aware of that deadline. Okay. So that's the last week is finals week. So the last week is finishing up stuff, no more new material, and you're doing the final exam, and we can talk about that when we should start opening that, because I have no problem opening that early if somebody's working ahead and is ready for it. It's a final where at this point I can give you away the secret. The lab portions where I ask you for parts of the body is also multiple choice. So you don't have to type. So that way your integrative thinking is not having to be as strong as in the second test, because you don't have to type, and then also, of course, I also don't have to go back and grade everything in hand, but it's a multiple choice. And so, to finish up, you guys have done great work this semester. And, this pathology project was a lot of work. And so I think hopefully the final should be sort of easy-ish going through it. And as we go through that thing of the final, make sure you look at the test review, make sure you look at the term list for the lab portion, the terms of the anatomy terms, which are basically all the labeling and coloring exercise terms combined on one list. And then also look at the bullet points of the questions, sort of written question parts that I describe, where I describe everything again in sort of, bullet point, main point format. Because if you have both those two documents next to you when you do the test, you should be just fine on that test. And then, after we're done, then at that point, we have pretty much the weekend where I can still, receive some pictures of a coloring labeling that you fell behind or so. But the test is unfortunately closed after the 26th, as well as the question.
Definitely don't need to be here. Yeah. Terrible. I am. See you later. I'm sorry. I'm about to put myself on mute. Sorry. I forgot.
No, it's okay. Yeah, so I can still accept sort of things like you can shoot me a picture and text me a picture until I put in the grades, and we go back and forth, and we can, also make sure your grade is what you expect it to be, because sometimes Canvas grade system is a little bit off, and so I hand grade everything at the end in terms of computing what's going on with that, and we can certainly communicate about that as well. I want you guys to have this be a successful finish up of the semester. especially the ones who've done a lot of work in it. All right, so any questions to that part, like the test where the test reviews are found and so forth? No? All right. Good. So how was the material this week? How was the respiratory system and the digestive system for you guys? Any?
I love the digestive system.
It's pretty.
I don't know if that makes me weird or not, but it was pretty. There's something about the small intestines that I got really excited about. I don't know.
Yeah, no, I mean the digestive system is really intense. I mean, I always find it fascinating how the neurology works together with it. How many nerves are actually in that gut, and how that gut feeling is really, you know, over time. Developing a good gut feeling is really something that's valuable in life.
Mm-hmm. Yeah,
and
true.
Fine-tuning that somewhat, and it's sort of, you know, we haven't always known that, but we know now that the gut has more neural connections to the forehead, which is the thinking brain, than the unconscious portion of the brain has to the forehead. So that's remarkable as far as
Really,
it's pretty remarkable. So yeah, when we so we're gonna do the second part here, but let's do the breathing first. So when we look at the breathing apparatus, we're looking at, you know, basically the system that brings oxygen into the body and from the atmosphere and gets rid of gases, waste when we breathe out again. And we can, you know, sort of, that's its main job. And then also it works on the acid-base balance and works together with the kidneys to make sure our blood doesn't get too acidic. And so the carbon dioxide and the bicarbonate ion, which helps balance out the blood this acidity works together with the lungs. And so the carbon dioxide, gets breathed out. And carbon dioxide gets created when we breathe and we split the oxygen, and we use that to create water and put the ATP back onto the ADP. When we look at the oxygen needs to travel through a few passageways, the air passages, to get to the lung tissue where it then can be exchanged and the gas can go over the tissue. And so we first actually have to go through the conducting zone. So if we see that up here, we see the upper respiratory tract, the lower respiratory tract, and the conducting zone is the upper part, is the nasal cavity, is the pharynx and the larynx, down to the voice box, so more or less down to the area where the Adam's apple is. And then below then we start having the lower respiratory tract. The lower respiratory.
Come with the meal.
Oops, we have somebody on mute. Everybody mute, please. Thank you. That starts with the trachea, which is what comes below the larynx. The larynx is the voice box where we create the voice, and the trachea is below. And then further down, we get into the bronchi, which feed the air into the lungs. The interesting part about the larynx and of mostly the trachea and then the bronchi is that they have cartilage in them, and so that they stay open, so the air doesn't have to push them open when there's no air for a moment, and they would collapse if there were no cartilage rings that hold them open. And so air is not as flexible, air is not as strong to be able to push those tubes open. So it has these cartilage rings that keep that, and they actually are horseshoe shaped. In the back they're open because in the back we have the esophagus that goes down, which we then have in that next chapter, the digestive system, because that's the tube from the mouth down to the stomach, and that can push into the back of the trachea because there's no cartilage in the back, and expand, and the bolus of the food can go down. And so that's sort of how that anatomy works. So that's kind of interesting. But you can sort of tell the ripples. If you feel ripples, then you know you're on the trachea. We also have these hair here, these ciliated cells that are in that area, in the tracheal, that pharynx trachea area, and they help bring they secrete sort of the mucus, the sticky thing, and they beat all the crap that we don't want there out of us, and so they bring the dirt and the dust as fast back out of the system as they can, because we don't want that to go deeper down into the lungs. And so that's what that is. And so when we cough stuff out, then the mucus, how that feels, that's because of that. The more irritation we have, the more mucus we sort of create to get rid of the stuff that we don't want. All right, so that's the upper air passageways. And then we have sinuses, and the sinuses help us. The upper air passages need to do a few things. They need to keep the passageways warm. They need to warm the air. They need to humidify the air. They need to purify the air, so on. So we hopefully do that, the purification we had through the cilia, and then the warming, the moistening we have sort of through the moist membranes in the air, in the passageways. And then the warming, partly that is done by the sinuses, which are air chambers inside the skull. The sinuses also warm, they warm the air, but they also make resonant chambers for the voice to get it's like a guitar chamber in an acoustic guitar, that air chamber makes the voice louder. So we have a few of those sinuses. The one that sort of gets us in trouble a lot is the maxillary sinus, because they have to drain into the nasal passages, and they all drain downward except the maxillary drain upward, and so that can stock a lot, and there's then accumulation of fluids, and that can create a pressure on the inside, and that gives us sinusitis. And then that hurts, because if this is clogged and you have bacteria growing in here, the pressure gets big, and that's not a good feeling. All right, from there we get into the larynx, which is the voice box. Well, first of all, we have the pharynx in the back here. We have three parts to the pharynx. We have the top part is the nasal. We have the middle part, nasal is to nose, pharynx, and so that's where that word comes from. Then we have the middle part that goes towards the mouth, and that's the oropharynx, oro as in oral, as in mouth. And then we have the below pharynx, the hypopharynx at the bottom, and that connects then down to the larynx or to the esophagus as we go into the digestive system. And then when we get to the larynx is, I've got to take a sip of water here. The larynx is interesting. That's where we make the voice box. I mean, that's where we make the voice. So we have these two cartilages, the thyroid, or there's one cartilage, but two sides to it, the thyroid cartilage on top here, which is big and wide in the front. And that's that Adam's apple pointer in the front with the guys. And then below that, we have another cartilage called the cricoid cartilage. And if we turn that whole thing, this is from the front look, and if we turn that thing around, we see from the back, the thyroid cartilage is pretty open in the back here. And the cricoid cartilage is sort of quite big in the back. And on top of those cricoid cartilages, we have these two, they call them arytenoid cartilages, which is kind of a, difficult name, but it's also an interesting name. And so those arytenoid cartilages, they can rotate on top, like around the vertical axis, going up and down. And they have vocal cords attached to them from their tip here in the front of there to the front of the to the back side of the front of the thyroid cartilage. And that looks like that there. So they're attached here. That's looking from above down. And then when that space then that gets created in here is the glottis. That's the space. And so the vocal cords, they open and close more, they get tenser and they get less tense, and that when we exhale, and then they vibrate, and that creates the voice. And that's phonation. And so that's how that works, sort of in a grocery view. And then we also have the epiglottis on top, and the epiglottis is helpful. So that's the flap. So that's that thing here on top, that flaps. We haven't talked about that. And this is the bone. This is the hyoid bone. So if you touch down in here, above the atoms, that big tip here, you go up a little bit, there's a bone. If you squeeze from the side, it kind of hurts. So that's kind of tells you it's on a bone. Don't squeeze too hard, otherwise it breaks it. So don't do that. But that's the bone that helps with swallowing. There's muscles attached. And when that bone, when we swallow, we lift up that whole larynx. And when we lift up the larynx, and the epiglottis stays in place, and this is a very flexible cartilage, especially around here, and that flap pulls down. And when that pulls down like that, it closes the larynx, and it closes the trachea, and so we don't swallow something by mistake into the air tube that needs to go into the stomach. So it puts like a roof over the trachea, or a roof over the larynx, basically. And so that's pretty cool. So if we actually, the problem is if we choke, wherever my choking picture went, somewhere I had a choking thing, maybe in a different chapter. If we choke, the problem is the food goes into the food tube, and it gets stuck right in here, and that's where the vocal cords are, the glottis. That hole is called the glottis. And if it's stuck where the vocal cords are, and you exhale, you can't exhale because the air can't get anywhere out here. And even if some air comes out, those vocal cords, it's like the guitar string is not loose, so you can't string it. It's not going to make any sound. So that's why the people that are choking can't make a sound. So you have to be careful and watch for that when that happens, and don't wait until they say, don't say, what's going on? Don't ask them, just act and do the Heimlich. Somewhere I have a slide on the Heimlich. We'll see if we touch on it. All right, so that's the epiglottis. Pretty cool structure. And then we go into the trachea. The trachea, we already talked about that horseshoe ring, how it doesn't close in the back, but in the front it's closed. And then at the bottom here, it splits into two, and we got one of these cartilages that has to split it, and that's called the carina. And the interesting thing about the carina is there's a reflex here, and if something falls down into it, we get a violent cough coming right back up, because we don't want it to go further down, because the tubes could just narrow and narrow and narrow, and at some point it gets stuck. But the further it gets stuck, the harder it's going to get to push out. So we might as well, get a reflex here and have a reaction that just immediately gets it back out. So that's when we have sort of the violent coughing reflex that's down in here. So that's kind of cool. And then we just appreciate how that bronchial tree gets from big to smaller to smaller to smaller to smaller. And at the end of the bronchial, where the terminal bronchiole is, so that's where we sort of finish ventilating the lungs. And then at that point, we have to have an air exchange happening. So that's where we get in what we call the respiratory zone. So we're not conducting anymore. We're actually doing the gas exchange. And that's happening then in the alveoli, or actually starts happening in the respiratory bronchiole. So the last portions of those tubes have little air sacs on them. And so that's where we already start exchanging gases. And so basically that looks like grapes on a stem, with all these grapes, and these round sacs are these structures that we have the air exchange. So that's where we have blood vessels clinging around, where we have blood vessels clinging around those air sacs. And so the air comes in, and the last part is an epithelial membrane. So that's a very thin, so that's a squamous epithelium. That's a very thin epithelial cells that are like, fine paper that you can see through or basically blow through, and things go through. So that's sort of a membrane that's that thin. And that is right next to blood vessels, and the blood vessels obviously is where the gas needs to go into. And so that's then done via diffusion. So that's a simple passing in from a higher concentration to a lower concentration of so that doesn't need any carriers or anything. So that's a good thing, because if we don't want it to needing to have ATP needs. So if it needs a carrier, it would need energy. And if you need energy to get oxygen into the system, that would be a really difficult thing to do. If you just think about the logistics a little, just the practicality or not, of it. Anyway, so that's pretty neat. So that's about that, what we want to know about that. And then the next interesting thing is the serous membranes. I'm trying to make sure I'm not missing anything here. And the serous membranes, we talked about that in the heart with the pericardium a little in the beginning there. But the thing that's really cool about the lungs, well, first, the thing with the serous membranes is this. It is when you cut through it, when you make a cut here, it looks like you have two membranes with this sort of a lucid space in between. It's a space that just has a little fluid in there, not much, just a film of fluid is in there. So you can't really necessarily make out that it's two membranes, but you could pull it apart. But what actually is the case is that this membrane is attached to one, these two membranes are attached to one another on top here and at the bottom here. And so it's actually one membrane that is going on outside of the lungs, outside of the lungs on the chest wall, and then right on the surface of the lungs, and it connects back out. So it's it's like a bag, like a balloon, and the lungs sit in them. And so there is this space in between. And in that space in between, we have a little film of fluid. It's called the serous fluid. And in the heart, the cool thing there is the heart pumps, and so it prevents friction on the outside. So it's not attached to the lungs, pulls on the lungs, for example. In the lungs, it does a little bit of that, but the other thing, the lungs, that's really cool is it suctions the lungs against the chest wall. And then when the chest wall expands because we breathe in over the ribs, or the diaphragm goes down, which is belly breathing, which is what we should be practicing because we get more oxygen into the system with belly breathing. The lungs that are attached to those walls, they get suctioned with the walls expanding or going further down, and that decreases the pressure inside the lungs, and that suctions air from the outside into the body. So there you have it. That's breathing right there. Does that make sense? Here we go. So we have these muscles here that are the breathing, the ones that pull the rib cage up and out. So that expands the volume of the chest that way, and then the diaphragm pulls it down, and so the external intercostal and the internal intercostals. And then exhalation is mostly a relaxation of the diaphragm, and it just pulls it up and we breathe out. But we can also have forced exhalation, and if we have forced exhalation, we have all of these other muscles. We have the intercostals that pull the internal intercostals that pull the rib cage downward and inward a little bit, and so they make it smaller, so they push a little more air out, for example. We also have inhalation muscles that help enhance the inhalation. We can pull the rib cage higher up and make a little bit more room that way. So the scalenes and the sternocleidomastoid, the SCMs, they can pull that thing up a little bit more, for example. So that's also the pec minor is also pulling it from the front up. We don't have a shoulder blade attached here. Anyway, so that's kind of interesting in terms of finishing up the breathing part. But that serous membrane suction to the lung thing, does that make sense with that film of fluid in between those membranes? Anybody?
It makes sense.
Well,
I went over the GI track with my other class and my nutritionist class. So this is kind of like going over some stuff I already know. We learned about the trachea and how food is a bolus. It turns into a bolus, like a lump of something to go down.
Yeah, and we'll do that afterwards. But the serous, how the lungs get suction to the chest and how the chest expands, and that does the breathing. That concept is okay in you guys, right? For you guys.
Yeah.
Okay, good. Then, and because the rest here is really not that much, I think, or a little bit. But the lungs, when we look at the lungs, we have the right lung and the left lung. right lung is divided into 3 lobes by 2 fissures, and those are just deep grooves in between the lobes, and the lobes are sort of independent lungs parts. So we have lobes, and then inside the lobes we have smaller segments called lobules. And so that becomes important when it comes to pathology, hoping that things don't cross over from one lobe or lobule to the next. And then on the left side, left lung only has 2 lobes and has 1 fissure, one of these deep grooves separating them, because we have the heart sitting in here, and so there's not that much room, so we just have 2 on the left side. So this is one place where the body is not quite symmetrical. And then these are these smaller lobules that I was talking about, or segments. And then the next thing that is kind of a discussion point is the respiratory volumes. It's like when we breathe, because we have this shallow breathing that we do when we sort of sit down and don't do anything, this sort of tidal volume, they call that. And then we can, from there, when we take a regular breath in, we can take a deeper breath in and fully inhale the lungs as much as we can. And we call that inspiratory reserve volume, because we have a reserve, that's there for reserve purposes, so to speak. And then we can also, though, go from the exhalation, exhaling normally, to exhaling as much as we can, and that's known as the expiratory reserve volume, same thing. And then in terms of when we look at what somebody's breathing is, how somebody's breathing is doing, we count all of them together. That's known as the vital capacity, and those are sort of the main ones that we need to sort of know. And then the residual volume is here after we forcefully exhale. Some gas stays in the lungs, and that helps us to, to be in, that's inside the lungs, that doesn't really get exchanged, and that's known as the residual volume. And then what else do we need to know about that? That's fine. Those are the main ones. And then we have the alveoli, and that's these air sacs. And when we look deeper inside these air sacs, we have couple type of cell types, and we call them pneumocytes because of the pneumois and lungs. And we have one type, that's the type 1 pneumocyte, and that's the cell that does the air exchange, that lets the gas go through. And then we have, and that's more sort of lines the air sac mostly. And then we have another type, the type 2 pneumocyte, and that's a cell that they realized later, because babies weren't viable for a long time, because that cell was not producing surfactant yet. And surfactant is a type, a fluid, a liquid, sort of a watery substance that has a little bit of tension to it, that keeps the air sacs from collapsing and gluing onto each other. And so it sort of helps create those air sacs. And so before we create that lubricant, the baby is not viable, and I forgot what week that is at this point. But that was the reason for a long time. And then once we figured out how to do that surfactant artificially, then we were able to have much more viability for preemies. And then we have a third cell type, and that's the dust cell. And I like that because that's a macrophage that keeps the alveoli clean. So I'm thinking that's sort of the vacuum cleaner that picks up the dust. And so that always sort of stuck in my head that way. And so that's pretty good. And then the last part is the gas exchange, the oxygen. So I said it was a diffusion. So that's simply a pressure question when we say diffusion. So when you put a sugar cube into a hot tea of just liquid, and it slowly diffuses and goes around in the whole water, especially if you swirl it around, but all the molecules want to be evenly distributed. It's not an osmosis or a filtration or anything like that. It's simply like we have an area where there is not as much oxygen, and we have an area where there is more oxygen. Then the oxygen wants to go from the outside to the inside. and balance out how it is on that. Same with carbon dioxide. So the crossing of the membrane is a simple diffusion. And the question is, where's the stuff attached to? And the oxygen is attached to the hemoglobin in the red blood cells. So that's how we understand red blood cells, what they do. They carry the oxygen. That's the main thing. And then the carbon dioxide, though, is mostly carried on the bicarbonate ions and not inside the red blood cell, and gets carried away that way. That's sort of a little next level detail mostly. And then this is an interesting slide. It just describes factors that influence how much an oxygen is carried by the hemoglobin. It's a dissociation curve. What dissociates? So, for example, if the tissue has a lot of carbon dioxide in them, if the tissue is very acidic, then we want more oxygen in that part of the tissue. So it's gonna make the hemoglobin less attracted to the oxygen, and that's what we call a dissociation curve. So that's kind of interesting. The body can fine-tune the hemoglobin attraction of the oxygen is fine-tuned to that level that it can read the level of acidity in a tissue, for example. So that's kind of cool. That's basically why I put that one up. We don't need to know all the details, but here are the details. This BPG is bicarbonate ions. And then we don't think we need to worry too much about carbon monoxide. Those are just poisons. On carbon monoxide, the problem is it's attached stronger to oxygen. I mean, stronger to hemoglobin than oxygen isn't. So that makes the tissue look very red, like you're oxygenated. You look like oxygenated, but it's a poison. And then the other thing here is if you have a baby and it has blue lips, you take it out of the water because it's a sign of cyanosis. So there is somewhere not quite an oxygenation of the tissue. And that's pretty good for that topic. Any questions on that? If not, we can go.
I'm good.
Good. Yeah, push me forward. So the digestive system, what do we learn about the digestive system? That's a pretty good system. So let's see. Yeah, that system is really interesting. We're looking at we first have to sort of break down that food stuff. I mean, that was always my misunderstanding, was digestion and absorption wasn't quite in my head right before I really learned it. So the first thing we have to do is we have to eat that food and break it down so the body can actually absorb it. So when your mom says, chew that sandwich 25, and you think thousands times, because you just want to sort of inhale it instead of chewing it. Well, there is a purpose why she actually says that, because we have to break down the food both mechanically with things like the teeth to chop it in half, or then later on the gut, because it massages it and then breaks it down to smaller pieces that way. When you hear the stomach growling and all of that sort of motion. But then also we have it chemically breaking down, and that's done with chemicals, substances that, like, you drop a little droplet on it and it dissolves things. And so that's what that does. And both of those start in the mouth, actually, and that's a very important place where we start the digestion, because we break the food down. We mush it together with some saliva, make it into a bolus that is much more manageable for the system, and more smoother also. And then also we stimulate that chemical digestion of carbohydrates, which is one of the major food groups that we'll learn this week in nutrition a little bit more. And so we have mostly, when we look at chemical digestion, I look primarily at enzymes that those enzymes that break down substances, that break bonds. Those are enzymes, and I look most of them for like major food groups, the glucose, the carbohydrates, the fats, and then the proteins. And so the ones for the carbohydrates start in the mouth. And so when you actually want to test them out, you can take a savory sandwich and just chew it as long until you smell the sugar in the bread, because it's sweet and your tongue picks up the sweet. And then you know you stimulated the enzymes to the level where there's enough breakdown that you can taste it. So then you certainly have chewed it enough. That's sort of a test you could do with your kids if they're like just inhaling the food for once. You can also squeeze or close the eyes and think of lemons, and then the amylase starts coming to the saliva, gets stimulated as well. And that's the other thing. When we start putting the food into the mouth and start eating, we stimulate. If we leave that food up there a little bit and think about it also a little bit, we stimulate the other parts of the system to get activated. So that's where you can do the test about the lemon, and you can just think about of a lemon, and you start having saliva coming out in you, and then your system in your stomach also starts getting hungry. So it's, in part we can sort of discuss and say that's that's really an interesting aspect psychologically or physiologically of the table prayer. Or in Europe we often, when we grew up, everybody had to sit down, and everybody had to wait until everybody sits down, and then you sort of say, have a good appetite, bon appetit. And even in that little moment, there is some physiology that gets activated just in that intention. And so that's one of the places where we can also see body-mind connection that is physiologically very established. It's not sort of like, we don't have to be new agey or anything to go to that place. So anyway, I always think that's cool. And so we have these two different types of digestion. And so when we start the mouth, well, in part we also digest it with the tongue, because the tongue, and of course this is not the real thing there. The tongue is a muscle, is extrinsic tongue muscles and intrinsic tongue muscles, and they help move the food around, and they help swallowing. And of course, the tongue also helps with speech. We haven't really gone too much into, we have gone into the speech, but not into the different vowels and consonants. The tongue helps with the consonants. It's the shape of the mouth. So that, and the tongue, we also have our taste receptors in the tongue, so we can pick up some rudimentary, like spicy, like salty, sweet, and sugary, and sour. Sweet is the same as sugar and sour. So that's not the chocolate. That we can pick those up as well, and then the rest is smelling that we pick up through the nose, the olfactory system of how the food tastes, in terms of what we consider how the food tastes. So taste is just what we pick up in the tongue, physiologically speaking. But when we talk about, food tastes good, then we combine the two, the olfaction as well as the taste buds on the tongue. And then the teeth, we briefly go about the teeth. Let's see, do we have, I don't think I have you memorized these teeth things. 2 rows of 16 teeth are attached to the maxilla and the mandible. That's what I want you to know. The rest you can look up. And so you see that also in the test review. There's not much more to it. But we have, some teeth that are cutters, some teeth that are grinders, some teeth that can tear well. So that's sort of what we want to know about the teeth. We have a formula here that I put up for baby teeth, and they should come out. I think that's a useful picture. I try to put things that are sort of also helpful for us in every day. If you have children, this is a place where you can go back, look it up. So that's hopefully helpful. And so when we chew this food and we we have it with saliva made into a bolus, then it's time to swallow. And the swallowing is interesting because it's when the bolus goes through the esophagus, and so the beginning of the swallowing is voluntary, and then after the food is somewhat further down, that choking thing type of thing, feeling at some point you can't control it, just is an involuntary reflex, and it goes down to the stomach via peristalsis. And we have a picture here of peristalsis where we look at pretty much the entire gastrointestinal system has two layers of muscles. And when we look at the layers, when we actually look at all of the layers of the thing, it has an inside layer that's called the mucosa. And we had that too in the blood vessels, it wasn't called glucose, it was called the endothelium. But it's similar. It's an epithelium. Different top structures, of course, different function from that perspective, but the same tissue type, the same type of fabric to line that inside of a tube. And then we have a muscle layer. Well, here we also have a submucosa. So that's actually, if you look at the big picture, that sort of mucosa, submucosa is one layer, because we always have connective tissue underneath epithelial tissue. And then in the tubes, we have a muscle layer coming. And in these tubes here, we have it be the muscularis is a circular muscle layer. And then on top of that, we have a longitudinal muscle layer. And then on the outside of that, we have what's known as a serosa. And that's the outside, or sometimes they call it adventitia as well, depending on what structures you're looking at. And that is a sort of a fibrous sort of connective tissue thing that can anchor the tissue. Well, this is actually a real R, so it also has a lot of movement, but it can anchor the tissue into the surrounding structure. And in the gut, it can help organize the tissue, because you have a long gut that needs to be organized. And so when the muscles contract, sequentially contract between the circular layer and the longitudinal layer, we create this peristalsis sort of movement, like this worm-like movement of forward motion. It pushes the bolus food forward in one direction. And so that's what we do. And we start that up when we swallow. So we start that up here, even though it goes down, it has that motion to it. So we can actually swallow even when we're doing a headstand. I mean, it's probably not the best, but when we joked, we talked about joking before. We want to do the Heimlich maneuver, and the Heimlich maneuver is when this is the sign of the being choked or choking, because you can't speak or can't scream or nothing. And so you do that, and then people know, oh, this person has some food stock in here. And what you want to do is you want to have a fist push into the stomach, because you want to increase the pressure in the stomach, or the volume of the stomach. No, we want to decrease the volume of the stomach, because you want to decrease the volume of the chest to force the air out, to push the object that's stuck in the larynx out of the mouth. And so what you have to be careful, though, is you have to make sure you go below the breastbone, because the tip of the breastbone, the xiphoid process, is very breakable. And if that breaks off, the diaphragm's attached to it, and it pulls it straight back, and it goes and pierces and injures the liver. And that's not good. And so what we learn is we put a fist. What we learn is we put a fist over the esophagus or the hand, and then go below that. So we're almost like just above the belly button, and that's where we put a fist that then goes in and pushes in and up and scoops up. And so that's the Heimlich maneuver. And so, be careful doing it. But if you're the only one doing it, you have to do it. So just be gentle with the xiphoid process, and push it in and up. And so the scoop it. And so that's sort of the motion that you want to do if you have to do it. And then here's a picture of how to do it on a baby. It's a little bit easier, because you can just sort of come from behind and push it on that part of that, like right below the shoulder blades, like where the low back becomes the mid back. There's a little bit of a divot, and you can just go push it in there. I had to do this once with my kid, since she had too much pizza too fast. And that came right out. That wasn't a big deal, but it still was the same motion. Because you start doing a little bit, and then you get a little stronger as it doesn't come out. Anyway, wanted to just briefly mention that. Learn this. It's good to know this one. If it's needed, it's really needed. All right, then we had the esophagus, and then from there we go into the stomach. And let's see what we need to know about the stomach. Well, the stomach is the important part about the stomach is that's where we really start digesting digesting the protein. And so we get into the stomach, and that stomach secretes a few substances to about the gastric juice look about 2 to 3 liters a day of a substance that's a pH of 1.2 to 2. If you put that on the skin, it's going to burn a hole into your skin. It's so crazy. And so that substance is very acidic. And so that's held inside that bag of the stomach. And it needs to be that acidic because it helps denature protein. So it destroys protein bonds, that acidity. So that's very helpful. And also it activates an enzyme that's protein splitting. And so the reason why we want to have it be a two-step process to get an enzyme that splits protein is because the damn body is so much made out of protein. We don't want all this active enzyme that can digest all our own protein floating around actively. So we have this like inactive enzyme called pepsinogen that is made as a precursor, and then we have a cell that secretes a type of cell that secretes hydrochloric acid. And then when those two combine, the pepsinogen becomes pepsin, and pepsin can digest protein. So that's pretty cool. Where is that thing? I should have just put the slide up that talks about that. So see here, the chief cell. The chief cell's sitting in here somewhere, down in here at the pit. So there's these things and these holes. It's like the holes you can see these little holes with the eyes you can see a little bit. It feels a little velvety, this whole thing. In there, it has up and down structures. And so the holes have these pits, have these different cell types lining them. And the bottom cells secrete pepsinogen. Pepsin pepsin digests protein, so P for P. But pepsinogen, a GEN, is a precursor of an enzyme. So when you see something, when you see pepsinogen, you know, when you see GEN, you know it's a precursor of pepsin, most likely. And if you see it that way, you know it's going to be an enzyme, because the enzymes are the things that need precursors. And then the parietal cells who come after that, they secrete hydrochloric acid, and that's the acidity part, the acid that activates the pepsinogen as it comes out of the pit, and then becomes pepsin. And so once it comes out, we can digest protein. And then we also have mucus cells, and they produce a protective mucus, because we want to make sure the lining of the cell of the stomach wall is protected and not, you know, eaten by the acid and all that stuff. HCl is also bactericidal. That's really good. And the parietal cells also secrete intrinsic factor, and that is important to activate vitamin B12. So that's an important factor. But vitamin B12 is more of a problem if somebody's vegan. You have to make sure you get that vitamin. All right, so that's pretty neat, I think, how that thing works. Any questions to that? This slide shows us the different phases. This is not for the test. I don't think I have a question on that. That's the test review. I'm looking at the test review myself. But it's kind of interesting to me and that's where it gets very complicated, right? The food stuff. It's the cephalic phase is taste, smell, thinking about food, stimulates the brain cells through the vision, through the vagus nerve, through that parasympathetic nervous system. So when you look at, it's interesting, when you look at the parasympathetic nerves, they come out from up here, the cranial area, and then the bottom, the sacral area. And the sympathetic nerves come out in between, next to the spine, the parasympathetic chain ganglia, they call that, in the low back and the mid back. And that's one reason why in my practice, I always work everybody's mid back. I don't do much cracking, but I make sure I mobilize it and it moves right, because that nervous system gets stimulated and gets balanced out a little bit. But anyway, that back to the gastric situation. The cephalic phase is initiated by seeing food, smelling food, and that starts making you hungry. That prepares your gastrointestinal system for food. And so there's, again, that point to be made, to be not just like, hurrying around and sitting in the car and waiting in line at a fast food restaurant and then eating while you're driving to work. That's unfortunately what we, end up doing sometimes. But we just need to be aware of it's not that ideal for the system, because the system cannot absorb the same quality and quantity of food if it's under those circumstances and on conditions, as compared to having it be really a festive, sort of way of eating. Take the time for that purpose, and again, maybe that's maybe where it comes together. Sit together as a family if it's possible, and that would be one reason why, because it's better for us. So anyway, so those are actually where the neurological parts are a little bit described, or how those influence the nervous system. We don't have to go into detail of that thing, because then we get into the small bowel. But that makes sense, how that's sort of helpful to see where that comes together with physiology. I'll take it as a yes. So then we get into the small bowel. The first step we have is the 12-finger duct, the duodenum, and the most important thing there is that's where we get most of the gastric juices, the intestinal juices coming in through the pancreas. Where's my pancreas here? Here we go. So the pancreas secretes a lot of the enzymes that the body needs to digest the fats and digest the carbs further and digest the proteins further, because those molecules need to be pretty darn small, like disaccharide type small, to be absorbed. And the absorption is what takes it into the small intestine from the tube. No, it brings it in from the tube into the, is this the right one? Yeah, into the blood system. And so it has to go through these cells that are the entero cells, right in here, and get transported into the different molecules, either into the bloodstream, that goes then to the liver for processing. So that's also interesting. The liver is sort of the first place where all the food stuff goes for processing. And then from there it gets distributed all to the body. The only thing is the fats, and the fats get brought to the lacteals, which is the lymphatic system, and then those molecules get dumped by the heart into the cardiovascular system, goes back into the cardiovascular system, and then gets brought to the liver for processing, and then distributed to the body. And so that's where we then get the HDL, LDL kind of discussion come back in. So I think that's kind of interesting. So that's absorption. So again, digestion is the breaking down of the molecules. Absorption is the bringing it in to the body from the gut tube, from the lumen, the inside of the gut tube. And here's that system that describes the stomach, and then how everything comes into the liver. Hepatic portal vein. See, that's the big thing here. Comes from all here, goes into the liver, and then into the inferior vena cava to the body. Gets distributed right away. All right, let's see what else we got here. Large intestine. Large intestine is mostly for water absorption, and we also have the good bacteria there that help decompose. Look, this moved. I'm sorry. Help decompose indigestible food items and are very important for our system, and that's because they also free up certain vitamins. And in mice, they've even shown that different bacteria in the gut, in the large intestine, help create excretions that then go to our bloodstreams or the mice's bloodstreams and make them happier or something like that. I mean, some weird stuff that is sort of feels goofy, but you know, we have to take it very seriously because we do have a big problem with the antibiotics. Overuse kills those families of good bacteria as well. It doesn't just kill the bad bacteria. And so if we give antibiotics for everything, we also going to harm the large intestine over time, because not all the bacteria families come back, especially if the kid is very young. When we get a little older, it gets a little easier. But even then, I would be, oops, sorry for that noise. I would be, you know, not opposing doctors saying, oh, you got to take the antibiotics, because if you need it, you need it. But make sure, you know, it's really necessary. Make sure you think of your own feet about it, especially if the baby is very little and has a lot of those ear infections, for example, that they give. Then, you know, start looking, make sure it maybe is exposed to getting the infections as much or so, because antibiotics are not harmless. They're life-saving, don't get me wrong. Anyway, but that's where I think what's important in the large intestine are these good bacteria. Then from the anatomy terms perspective, we really have not that much of a cecum and an appendix hanging up, and then an ascending colon, transverse descending colon. We have these haustras, and we have these flexures here, and we have these ploic appendages. Where's those haustrum, these little houses? This haustrum is one. Where's the epiploic appendages, or here these little fat thingies. And then we have one muscle here, it's called the tinea coli, that sort of hangs everything together. So that we don't have any, you know, peristalsis really happening down there. We just really get the water in and get these commensals, and the material gets more compressed. And then we have the sigmoid colon as it comes down, and then the rectum into the anal canal. And then we get the stuff coming out of the system from there. And so that's about it for that. And then I think the rest is a little bit on the liver that I wanted you to know. Basically, is that the liver is the largest exocrine glands that we have, and it metabolizes all the food things. We talked about that. So they all go straight from the stomach, the protein substances, the water, basically the water soluble substances go straight from the gut to the liver, and the fat soluble substances go first to the lymphatic system and then into the cardiovascular system by the heart, and then to the liver for processing. And the liver helps also detoxify us, so it inactivates medications and other poisons. So that's another one of those we need to be a little gentle about, is too much medication. It's the kidneys get harmed by medications or taxed, depending, and then the liver. And so with the liver, we have to we want to be gentle about the acetaminophen, because that's one that is in everything, and it's also one that can be acutely overtaxing the liver. So that's just one where it's like, if I, you know, take Tylenol, I don't want to do the beer as well the same day or something like that. At least food for thought. So that's because the liver is a fantastic organ. It's a gland. The gland is a epithelial tissue. The epithelial tissue is very regenerative. It always grows, and so that's very helpful. Also, we have the bile here. We have the gallbladder here, and so the liver secretes the bile, and then the bile gets stored in the gallbladder, and then it gets secreted to the pancreas. And the bile helps us emulsify the fat, and so the bile is an interesting substance. Bile salts or bile salts are hydrophilic on one side and hydrophobic on the other side. And so what that does, it basically is kind of like a phospholipid. So it can engulf a fat droplet and have the hydrophobic part on the inside and the philic part on the outside, and the hydrophilic part wants to be around water. So you can make these little small water droplets or fat droplets that are you're able to dissolve in water. So that's kind of cool. I really think that's cool. And so I think that's it as far as I'm concerned in terms of what the most important pointers are of this topic here. Any good with you guys? Sorry, I know I realized I'm going a little bit slow here. But for this,
I agree. I'm listening, tuned in.
Okay, good. So because for this week, what I want you to do is, I want you to keep working on the video presentation. So I put it actually here on this week, and I'm going to expand that to the 26th. And so once you've done the video, once I've given you points, wherever that other thing is, where was it? This one, week 13, on the video, then uploaded onto this it's in this week's, but then you upload it, which is week 15, you upload it into here. And I'm actually still working on the text edit. I realized I have to edit this text a little bit, but basically what I want you to do, I said it at the beginning of the presentation, write a little description where you sort of sell your video, why, maybe why you chose it, why you think it's important, it reaches that many people, affects that many people, and blah, blah, blah. And then upload your link, your video, your presentation, and then you go and look around and look at what you like and choose at least 2 of them that you watch. And I would like you to go, and answer sort of the following questions. What are the main points you've learned from the presentation in your head? And then also give the presenter feedback, what you like about the presentation and how they present it, and give one tip how to make the presentation better, and sort of present it, be kind about it, but give him a way to also make it better. Like, the font was a little small. I couldn't quite read it. If you make 2 slides out of it with larger font, that might be easier to read. Something like in that direction. So that also helps you guys learn a little bit how to give good feedback. And then and then actually, if you get the feedback, if you please, on this discussion, could repost to the person as a reply and say, thank you, or, something like that. That's the only discussion I would like to have, that last feedback going back. And so we want to finish this entire thing by the 26th. So you have a little time, but if you already have done your video, go upload it, do it, okay? Get that going. And that way we can get started with that. And so you do that as soon as I give you credit under week 13. Okay, and then the other thing this next week we're going to do is we're going to look through the urinary system and a little nutrition. So that's a fun one, kind of. We then some questions, and then the urinary system. And there we have a little bit of coloring. And then that's the end of this week. And then next week, we're going to do the reproductive and the embryology. And then we're done with the semester. So this is sort of the last. Oh, and I think we also have still the gratitude discussion. Do we have? No, we finished that. We're still going to have the food journal discussion. Finish that up, I think. Is that right? I have to look that up. I think that might be the last week. Oh, that's here, the last week. Okay. So you guys still working on the food journaling this week, I think. Okay. So that's it as far as I'm concerned. How are you guys?
Things are good.
Questions?
Phyllis says things are good. When the rest of the class leaves, I'd like to talk to you, Phyllis is saying.
Okay. All right. Well, if nobody has any questions, then we can close it out.